Good day, class. Today we will be talking about new topic, which is the fluid statics. Okay, so first, what is fluid statics? So fluid statics is the branch of fluid mechanics that studies incompressible fluids at rest. Okay, so yung subject natin is fluid mechanics. So we have fluid statics and fluid dynamics. So statics, keyword is fluids at rest. So statics means stationary. Okay? Or in more technical term, kung makikita nyo dito, we have here fluid particle. So this fluid particle is instationary, meaning hindi siya gumagalaw dahil balance yung force niya. So in technical terms, force is acting on that body is balance. So we have here weight and the net force of pressure. So dito sa isang figure, there's a pressure distribution. So may pressure pababa and also may pressure pataas. So let's say hindi ito fluid particle or an object, a solid object, pwedeng buoyant force itong pataas na force. And also weight. Ayan, so balance silang tatlo. Kaya nasa stationary position or fluid at rest. Okay, so now let's talk about pressure. So pressure is defined as the ratio of normal force to area at a point. So bakit at a point? So for example here, yan, meron tayong let's say soccer ball or a balloon. Yan, ito yung cross-sectional ano niya, area. Ngayon, merong hangin sa loob ng sphere or object. And let's try to get a very small, let's say, a particle or molecule. So itong molecule na to, uh, nagbibigay siya ng force dun sa wall nung, let's say, soccer ball or a balloon. Ayan, so we have here a finite area. Ayan, so sa area na to, merong force. So, yan, at each point in the wall, this pressure distribution creates resultant force. Ayan, so we have here normal force, delta F normal, exerted on a finite area, which is delta A. Okay, so pressure is equal to the limit of this ratio, delta F over delta A, as delta A approaches to 0. Ayan. Or dF over dA. So mas mag-work sa atin yung ganitong form ng pressure. Dahil not all surfaces pare-parehas yung pressure na ma-experience nila. So may mga ganun tayong case. Hindi not all the time pare-parehas yung pressure distribution. So kaya gumagamit tayo ng ganitong expression. Well, simply pressure is normal force divided by area. Okay, so ayan, so ito a pressure is a scalar quantity. So pag scalar, pag sinabi natin scalar, it has magnitude only. So it has no direction. Unlike sa vector quantity, meron siyang magnitude and direction. So we have a concept which is pressure is not a force. So rather it is scalar that produces resultant force normal to the area. Ayan. The resultant force acts on a direction towards the surface. So, yung force lang is towards the surface. Wala siyang tension force. So, lahat lang compressive. So, push lang siya. Walang pull. Okay, so known units for pressure are Newton per square meter or Pascal. Pwede ring PSI in English, pounds force per square inch. And PSF, pound force per square foot. Okay, so meron ding pwede ring ATM, torr, or bar. So yung ibang application, other units for pressure give the height of a column of liquid. So okay, pwede rin yun. Height ng column of liquid. So in this case, makikita nyo dito sa figure, we have here balloon. Siyempre mayroong pressure dyan, or may air sa loob, may pressure. So dahil may pressure sa loob, meron kang nakakabit na U-tube or manometer. So itong U-tube na to merong liquid or specifically water. So syempre yung pressure sa loob, ipupush niya yung liquid palabas sa atmosphere. Pero yung kaya niya lang i-push is at a height of 8 inches water gauge or 8 inches H2O. So pwede rin yung fluid is mercury. So depende rin yan. So pwede mo siyang express as the height of column of liquid. So yung mga iba't ibang conversion factor or iba't ibang unit or values ng pressure is matatagpuan nyo sa PDF nyo sa table F.1. So yan. Ayan, so we have here standard atmospheric pressure. So ito sa Earth, we have this standard pressure which is the air pressure at sea level. So can be written using multiple units. So take note class, magbabago ito depende sa height. Okay, so strictly dito lang siya sa sea level. So pwedeng 1 atm, 101.3 kilopascal, equal din siya sa 14.7 psi. Equal din siya sa 33.9 feet column of water. Ayan. So, pwede rin siyang 760 mm column of mercury. Or, in inches, 29.92. And 2,116 pound force per square foot. Okay, so meron tayong tatlong type ng pressure. We have gauge pressure, absolute pressure, and vacuum pressure. So, ito yung definition nila. So, gauge pressure is when pressure is measured relative to existing local atmospheric pressure. So, si gauge pressure, pag binigyan ka ng gauge pressure, it means yun yung pressure above the local atmospheric pressure. So, for example, nagsukat ka ng pressure sa tire. Yung niregister nung machine or nung equipment is 300 kilopascal. So, since this is relative to existing local atmospheric pressure, so, di ba, ang local atmospheric pressure natin at sea level is 101.3 kilopascal. So, ang mangyayari, sulat natin dito. Ang mangyayari, so let's say, yung P gauge mo, P gauge is equal to 300 kilopascal. Yung magiging absolute pressure mo is equal to, mag-a-add ka ng atmospheric pressure, which is 300 plus 101.3. So, more or less, nasa 400 or 401 kPa. So, ito yung absolute pressure. Itong 401. Yung 300, ito yung gauge. Yung 101.3 is the atmospheric pressure. Okay, so meron namang absolute pressure. The pressure in a perfect vacuum is called absolute zero. So dito kasi dinerive yung absolute pressure. And pressure measured relative to the zero pressure is termed absolute pressure. Okay, so nag-start kasi ang reference ng absolute pressure is absolute zero. Okay, so pag binigyan ka ng absolute pressure na ayan, 300 kilopascal, so kaya siya 300 kilopascal kasi 300 plus 0 is 300. Ayan, so it depends kung ano yung atmospheric pressure. So kung sa outer space ka, of course, zero yung local atmospheric pressure doon. Ayan, so kung ano mang ma-measure mong gauge pressure, let's say 300 kilopascal, yun din yung absolute pressure. So kung nasa Earth ka or sea level, yung absolute pressure mo, given 300 kilopascal yung gauge mo, will be 401 kilopascal. Okay, I hope na intindihan yun. Also, we have vacuum pressure. So vacuum pressure, take note, it is always less than atmospheric. Okay, so it is the difference between atmospheric pressure and actual or gauge pressure. So kung ano mang difference nitong absolute pressure and gauge pressure, yun yung vacuum pressure. And also, pwede ring express yung vacuum pressure as ito. So we have here mathematically, gauge pressure is equal to negative of vacuum pressure. Ayan. So, pag binigyan ka ng vacuum pressure na 15 kilopascal, yung gauge pressure mo will be negative 15 kilopascal. Okay, so ito yung iba't ibang mathematical representation ng pressure. So gauge pressure is equal to absolute pressure less atmospheric pressure. So kung nasa outer space ka, syempre zero ito. So this will be equal. Also, we have absolute pressure is equal to atmospheric pressure plus the gauge pressure. So yun, pag binigyan ka ng gauge pressure, i-add mo agad yung atmospheric pressure. Also, absolute pressure is equal to atmospheric pressure minus the vacuum pressure. So, kung binigyan ka ng vacuum pressure na negative na, so negative 15, wag mo nang gawing positive. So, lagi kasi itong minus. Okay, so baka kasi mangyari, to get the absolute pressure, ginawa mo atmospheric minus negative 15, let's say. So mangyari, mag-add ka ng 15 kilopascal. So hindi na siya hindi na siya vacuum yung 15. So dapat lagi tong minus. So absolute na lang to. Laging positive yung Pvac para minus yung positive value ng P vacuum. Okay, so vacuum pressure is equal to yun, negative of gauge pressure. Also, P vacuum is equal to atmospheric pressure less the absolute pressure. So ito, meron tayong diagram para mas madali nating ma-visualize yung tatlong pressure na to. Okay, so let's start dito sa ito. So ito muna, yung line na to. Ayan, so simula dito. So itong height na to, ito yung local atmospheric pressure. So we have 101 kilopascal absolute. And yung bottom is 0 Pascal absolute. So ito yung reference line. So meron tayong dalawang pressure, PB tsaka PA. Si PB, yung pressure niya below atmospheric pressure. Kaya masasabi natin si PB ay vacuum pressure. Okay, so ayan, sulat natin dito. So ito, PV is vac. Yan, si PA is above at local atmospheric pressure. And so, let's say, binigyan ka ng gauge pressure na 200 kilopascal, or dito tayo sa English naman, 28.9 PSIG, i-add mo ngayon si 28.9 PSIG sa local atmospheric pressure to get the absolute pressure na PA. So, we have local of 14.7 PSIA. So, 14.7 plus 28.9 is equal to yan, 43.6. So, masasabi natin na si PA is equal to 14.7 plus 28.9 equals sa 43.6 PSIA. Yan, pag may nakita kayong unit na PSIA na, absolute na yan. Huwag na kayong mag-add ng 14.7 PSIA. Okay, so that's the pressure above atmospheric pressure. So how about pressures below atmospheric pressure? So automatically that is considered vacuum pressure. So si PB, pag binigyan ka ng, syempre yung gauge pressure niya is negative 7.2 PSIG. Ayan, so yung gauge pressure niya daw is 7.2 PSIG, or in vacuum pressure naman, positive yun. So 7.25 PSIA. And so gamitin natin, so to compute yung absolute value ng PB, PB abs na lang para. Yan. So pili tayo dito sa formula. So pwede natin gamitin ito or ito. Okay, so try natin gamitin itong PATM plus P gauge. PATM plus P gauge is equal to, okay, so ang atmospheric pressure natin is 14.7 PSIA plus yung gauge pressure. So any pressure below atmospheric pressure is negative gauge. Okay? So pag vacuum pressure, positive yon. So pag gauge, ginamit natin yung PSIG, negative dapat yung ilagay natin dito. So negative 7.25 PSIG. Ayan. Para pag mag-subtract sila dito. So ang absolute pressure pala ng PB is 7.45. So pwede natin itong lagyan ng PSIA. Ayan.